Hi guys, welcome back to channel. As per title of video, we will discuss about MCQs in question paper of December 16, means CSIR-UGC-NET December 2016. So let's start the video. Here, first question in part B, which is in hydrolysis of trans COEN2ClA plus, if leaving group is chloride, the formation of cis product is least when A is A NO2 minus, B NCS minus, C Cl minus, and D OH minus. So the formation of cis product is least, means formation of trans product is more when A is. In compound trans COEN2ClA plus, Cl is leaving group, means this is leaving group. If ligand have more trans effect, then trans product obtained will be major and cis product will be least. So in the given ligand, NO2 have higher trans effect than others. If NO2 is present in complex, least product is a cis. Here order of trans effect is NO2 having large trans effect, then NCS minus, then Cl minus, then OH minus, means trans effect is more, then trans product is major. So NO2 having major trans effect more, so major trans product is formed when A is NO2 minus, means cis is least. Option A is correct. Second, the rate of alkene coordination 2-PTCl4 2- is highest for option A norborane, B ethylene, C cyclohexene, and D 1-butene. So as the electron density of pi bond increases, rate of coordination increases, means electron density of pi bond directly proportional to the coordination rate. In this option, norborane having highest electron density of pi bond, so the rate of alkene coordination 2-PTCl4 2- is highest for norborane, but the decreasing order of rate of coordination of alkene is decreasing order. Norborane having highest, than cyclohexene, then 1-butene, then ethylene. So the rate of alkene coordination 2-PTCl4 2- is highest for norborane. 3. The correct order of bond dissociation energy for indicated CH bond in following compound is: first benzene, second cyclopropene, third phenylacetylene is given, So the bond dissociation energy for the benzene is 472 kilojoule per mole. Then cyclopropene is 436.4 kilojoule per mole, and phenylacetylene is 557.8 kilojoule per mole. So as per bond dissociation energy, C is more than A than B, means option D is correct, which is C having bond dissociation energy greater than A than B. H1 NMR spectrum of mixture of benzene and acetonitrile shows two singlet of equal integration. The molar ratio of benzene as to acetonitrile is option A 1:1, B 2:1, C 1:2, and D 6:1. So we know that benzene have 6 proton, 6 hydrogen, or acetonitrile CH3CN having 3 hydrogen. You know that to obtain equal integration we require same number of hydrogen for this. So molar ratio of benzene and acetonitrile is 1:2, because benzene having 6 hydrogen as to 3 hydrogen. For integration 1:2. So option C is correct, which is 1:2. H1 NMR spectrum of mixture of benzene and acetonitrile shows two singlets of equal integration. The molar ratio of benzene as to acetonitrile is 1:2. 5. Number of signals present in the proton decoupled C13 NMR spectrum of following compound is given here. In this compound there are two benzene rings attached to each other by carbon or Br. Option A is 4, B 6, C 8, and D 10. So this compound having plane of symmetry, here plane passing in this way. So we know that C13 NMR is depend upon types of carbon atom present in the compound. Depend upon types of carbon present in compound. Given compound having plane of symmetry and having 4 types of carbon, which is first carbon is this, then this is second carbon, third carbon, and fourth carbon. In this way, here also first, second, third, and fourth. So there are 4 signals present in C13 spectrum of this compound. Option C is correct, which is 4. If you have any doubt about this, then you can mention it in comment box. Thank you for watching this video.